I want to explain classification of amplifiers based on input and output impedances. Actually, we left with the topic, the negative feedback modifies the input and output impedances. Okay, to explain it in detail, we need this concept classification of amplifiers based on input and output impedances. Okay, so now we'll see classification of amplifiers based on input and output impedances. Yes, amplifiers are classified into 4 types based on input and output impedances. Those are voltage amplifier, and second, current amplifier, third, transconductance amplifier, and the fourth, trans resistance amplifier. Okay, so now for all these 4, I'll draw the equivalent circuit and I'll see how the input and output impedances. So first, let me draw the voltage amplifier circuit. Yes, in the input side, it consists of 2 resistors, Rs and Ri. And we know at the input side, we generally give Vs, and the voltage across Ri is your actual input voltage. And for the output side, your voltage amplifier circuit consists of, yes, a dependent voltage source AVVR and 2 resistors R0 and RL. Okay, the voltage across RL is V0. So this is the equivalent circuit of voltage amplifier. Now the required thing is, see, V0 must be equal to AVVI. Means all the AVVI voltage must present across RL. When it can happen, see here at the output side, you have 2 resistors R0 and RL. So what is that? There exists voltage division. This voltage gets divided into 2 parts. One is across R0 and another one is across RL. But our requirement is voltage across RL is completely your AVVI. Means the drop across R0 must be very less. When the drop across R0 is very less, when the value of R0 is very less. So to have this, your R0 must be very less than RL. Okay, so that is one point. Another point, see here, it is the VI. That VI must be equal to the total input voltage. What is the total input voltage? Vs is the total input voltage. When this VI is Vs, yes, when the voltage across Ri is equal to Vs, when the value of Rs is very small. Because here also in the input circuit you have 2 resistors, Rs and Ri. There exists again voltage division. So what will happen? Yes, this voltage gets divided across Rs and Ri. If you take Rs of very small value, then automatically all the voltage appears across Ri. So, okay. So, yes, Vi is Vs when Rs is very less than Ri. Okay. So, if you observe these 2, yes, your output impedance is lesser than your load impedance and your source impedance is less than Ri. Okay, so if you write it clearly, I can write it as Ri must be greater than Rs and R0 must be less than RL. Okay, so these are the input and output impedances of your voltage amplifier. Ri must be greater than Rs and R0 must be less than RL. Okay, so this is about voltage amplifier. And another important point is, see here is a factor called AV. What is this AV? if you observe this V0, yes, V0 is equal to AV VI. What is AV? AV is equal to V0 by VI. Okay. So what is this V0 by VI? Voltage gain. Okay. Hence this circuit serves as voltage amplifier. Yes, input is voltage, output is also voltage, and this factor is your voltage gain. Next we'll see the second circuit, current amplifier. Yes, your current amplifier circuit consists of a current source, IS, resistor RS, another resistor RI, all the three are in shunt. Next, at the output side, you have a current source, AIII, and you have a resistor R0 and another resistor RL. The current through RL is IL is nothing but I0. Okay. Now, see here, the current here is II. Your II must be equal to IS. And here, IL must be equal to I0, that is equal to AIII. Okay. So, yes, see here, IS comes like this. At this node, it gets divided into two parts. Okay. Yes, this part and this part. To get II, that is equal to IS, the current should not go to RS. Okay. Means RS, you must keep RS of very high value. Then only the current enters into RI. The total current enters into RI. Okay. So, what is the first condition? Yes, II is equal to IS when RI is very, very less than RS. Okay. Yes. Then, what about that? IL is equal to I0. That is equal to I0. That must be AIII. When it will happen? Here also, the current enters this node. It gets divided into two parts. Okay. All this current must enter to the RL only. There should not be any current through R0. Means R0 must be very, very high. Okay. So, I0 equal to AIII when R0 is far greater than RL. Okay. So, what are the conditions? Yes, this circuit serves as current amplifier only when RI is very less than RS and R0 is very greater than RL. Okay. And if you see this expression, what is AI? AI is equal to I0 by II. Okay. What is this? This is nothing but current gain. Nothing but current gain. What is this? This is nothing but voltage gain. Here we got voltage gain. Okay. Thus V0 by Vi is your voltage gain. Okay. So that is your current amplifier. Say here for the voltage amplifier, Ri is greater than Rs and R0 is less than RL. And for the current amplifier, Ri is less than Rs and R0 is greater than RL. So, if you observe these two, completely you got reverse values for input and output impedances. Okay. Then, the third circuit is transconductance amplifier. Yes, the circuit consists of yes. This is the transconductance amplifier circuit. Here also, say this. The first part of the circuit
very similar to the voltage amplifier, and this output part is very similar to the current amplifier. Okay, so here, so what will happen? To get Vi equal to Vs. Yes, Vi equal to Vs when Rs is small. When Rs is very, very small, means Rs is very, very less than Ri. Okay, means this condition holds good. Okay, means your Ri is far greater than Rs. Okay, then here, to get I0 is equal to GMVI. Here is a current source. It's dependent current source of value GMVI. I0 is equal to GMVI, yes, when R0 is very high, okay, when R0 is far greater than RL, okay. So these two are the conditions of your input and output impedances, okay. See the first part, Ri is far greater than Rs, so that is from this voltage amplifier, and R0 is far greater than RL from the current amplifier, because input circuit is similar to the voltage amplifier and output circuit is similar to the current amplifier. Okay, and see, what is this GM? GM is equal to I0 by Vi. I0 by Vi. Yes, this is called transconductance. Why it is called transconductance? First of all, it is called conductance because it is I by V. Why it is called transconductance? Because it is the ratio of output current by input voltage. Okay. So, if any parameter deals with output and input, then you can call that parameter with the, yes, by connecting the word trans. Okay. So, that is the reason it is called transconductance, and this is your transconductance amplifier equivalent circuit. Okay. Now, we'll see the last one, trans resistance amplifier circuit. Trans resistance amplifier. Yes, the equivalent circuit is, the input circuit is similar to the current amplifier, the output circuit is similar to the voltage amplifier. Yes, this is Is, Rs, Ri, and there exists a voltage source, dependent voltage source RMII, yes, this is R0, RL, and the voltage V0 is the voltage across RL. Okay, so this is your II. Okay, so here also your II must be equal to Is. Actually, the current enters here and it gets divided like this. This current entering into the Rs must be very, very small. Okay, then only the entire current II is equal to Is. So, Rs must be far greater than Ri. Okay, for what? Yes, it implies, it gives II is equal to Is. Okay, in a similar way, here V0 must be equal to RMII. Means the voltage drop across R0 must be very, very small. When the voltage drop is small, when the resistance value is small. Okay, so you'll get to V0 that is equal to RMII when yes, R0 is far less than RL. Okay, so what are the two conditions? The two conditions are, yes, this is one condition and this is another condition. Totally I will write clearly here, Ri must be far less than Rs and R0 must be far less than RL. Okay, so this is the conditions for input and output impedances in the case of trans resistance. Okay, so now if you observe V0 is equal to RMII, your RM is V0 by II. Okay, it is called resistance because it is V by I. Why it is called trans resistance? Again the same region, it is output voltage by input current. So that's why it is called trans resistance. And this amplifier is a trans resistance amplifier. Means it is taking the input current and it is amplifying it and it is giving it as the output voltage.
giving output as current. In the case of voltage amplifier, it is taking the input voltage and it is giving the same voltage as output. Okay, so this is the classification of amplifiers based on input and output impedances. Okay, so let me write the total input and output resistances of all the amplifiers.
Input impedance and output impedance. So what is the first one? Voltage amplifier. Okay, for the voltage amplifier, Ri is greater than Rs, R naught is less than Rn. Ri is less than Rs and R naught is greater than Rn. And for the trans conductance amplifier, yes, this is the trans conductance. Ri is greater than Rs and R naught is greater than Rn. Okay, input, then the trans resistance. The trans resistance here, Ri is less than Rs and R naught is less than Rl. Okay, so this is the table. Okay, that shows the input and output impedances of your 4 amplifiers. This table is very much needed for further analysis. Means after introducing a negative feedback in all these 4 amplifiers, then automatically the input and output impedances are going to be changed. Okay? Yes, now here how to remember these values? I have a trick. Okay? I used to tell to my students, the trick is Ri greater than Rs. Just you keep like, as Ri is high, just remember with the letter H, high. H for high. R naught is less, so L. Okay, so this is Ri less, L. R naught high, H. Both are high, so H, H. And both are low, L. So simply, instead of remembering all this greater, lower, lesser like this, simply you just keep the sequence: voltage amplifier, current amplifier, transconductance amplifier and trans resistance amplifier. And then just keep high, low, low, high, 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 low, low. Okay. So just HL, LH, HH, LL. That's all. You're going to get all these values very quickly. Okay. So this topic is very clear to all. If you like this video, please don't forget to like, share and subscribe. Please share about this channel to your friends. Thank you. Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.